after all the lectures in the microwave, I want to take a random lecture which are kind of FAQs in few examinations. First is I would like to show how the fields exist in strip line and microstrip line. This is the diagram for strip line where always H field lines are circular lines, closed lines. That's what del dot B will be 0. This indicates H field lines are always closed loops, and these are the E lines because there is a ground plane on top of it. But when we come to the microstrip lines, because there is no ground plane on the top, we don't have an exact TEM wave as I said before. This is a quasi-TEM wave. That is, the waves are like this and they go like this. The H lines are as usual circular lines. Now we go for the cutoff frequency derivation. The cutoff frequency derivation is this is the phase velocity, this is omega, this is beta, and I've already said about this relation which is very important. H square is equal to omega square, H square is equal to gamma square plus omega square mu epsilon. C is 1 by root mu epsilon. Now we have derived, while deriving the field equations of parallel plate waveguide, I have shown that H is equal to m pi by A. This is the condition that we obtained after substituting the boundary condition. So that I put it here. So gamma bar is equal to under root of H square. This is H square minus omega square mu epsilon. H is m pi by A. So now if there should be propagation of wave in z direction, this gamma should be imaginary. Gamma is alpha plus beta, alpha plus j beta. If this is less than 0, then only it will be imaginary. That is this condition. But this condition is where gamma is real, but we want gamma imaginary. So gamma's omega square mu epsilon should be greater than m pi by A whole square. So when according to this condition, only the imaginary part exists, that is j into beta. This will also be j into this part. So j cancels and we get this. But for cutoff frequency means where gamma equal to 0. That is this condition. But we know omega is equal to 2 pi f. So omega square is 4 pi square f square. 4 pi square f square into mu epsilon is equal to m pi by A whole square. So according to this, if we solve, we get this. This is the derivation for cutoff frequency. All the waves which have cutoff frequency greater than this frequency will only propagate. That is, if we have like this, if this is Fc, all the waves that have Fc greater will only propagate. That is, this is the frequency response of a high pass filter. So waveguide can be considered a high pass filter. And now when we consider about the assumptions made during the derivations of the field equations, these are the assumptions that we made. This is an important thing that has to be noted. We assume that the field is not varying in the y direction. That is why we make dou by dou y equal to 0 in all the derivations as I have indicated previously. And the second assumption is there is variation in x direction only and the propagation is along z direction. That is, we already assumed dou by dou z is minus gamma bar. And this is what we have. And this is a diagram showing relation between phase velocity and group velocity. We saw Wp is equal to C by cos theta. Wg is equal to C into cos theta. Wg is equal to C square. So based on these relations, that is substituting f, this cos theta can be written as root over 1 minus f by fc whole square. So based on substituting this will be fc. Based on substitution of this, you get the phase velocity and group velocity as indicated here. Now coming to the wave impedances, as I have already dealt. Now we are going to derive the wave impedance of TE and TM waves. ZTE is, we know that we are considering EY and HX. I already said if we write impedance as EX by HY, then it is positive. But if we are writing EY by HX, then it is negative. We are writing the same thing here. And we are substituting for the field equations, and we are substituting gamma is equal to J beta. So J and J cancels. That is J and J cancels and we get this. Now if we want to write JYX, that is it indicates EY by HX. Because H is varying, E by H cos theta. E by H we know it is eta. The free space impedance is considered eta. So eta by cos theta. We already know that cos theta is root over 1 minus fc by f whole square. So we are substituting it here. Now for Tm, it is the opposite. Zxy, that is Ex by Hy and E cos theta by H. E by H is usually eta cos theta. And the same cos theta is equal to root over 1 minus fc by f whole square. And we know that Zte into Ztm will be eta square.